Hi guys, my name is Yogesh. I am from Qualcomm Hyderabad, and today I am going to discuss how Qualcomm is bringing its own lab to support our upstream targets, to validate them, to publish these results and all sort of information. A little bit introduction about me. I'm a staff engineer at Qualcomm working on the kernel development. Also have some background on CI/CD pipelines. So today's agenda we will cover about like what problem we face while going all those things and the proposed solution. There are multiple things and what we opt for, how we did it, the results, few results of a few of the platform which we already supporting on the dashboard, challenging and the summary. The problem statement was like it was clear that we want to make the upstream kernel more stable, especially on our Qualcomm chipset, which having bit of kind of a loosey testing here and there because till now we was not involved in much of the testing of these platforms. So that is the one motivation factor why we did it. And other thing is to be committed to the upstream or open source community and to support our Qualcomm platform and take the ownership to make it kernel more stable and reports whatever the problem and all those kind of things. Okay. Now the proposed solution. So this was new. So we want to see how we can make it very much community oriented, accessible to everybody, especially about the reports and whatever the bug reporting and all the things. So make it open. So the main aim for us to use open source tools only. So nothing in build. Also, we may, if we are developing something internally, we will be open sourcing it. So that is the main thing. And the other thing is to generate the report in such a way it will be very helpful for all the maintainers and the general public to consume it. So that is the main thing. And the key factor, like provide a stable, productive support for Qualcomm maintained platform. So that is we have lot and lot of platform, but I think in the community only very key platform reports is getting populated, not the other tiers. So that is the main thing. So now how we did it. So we were thinking about to like where to start and we were having some ideas. Then we came across the community called KernelCI.org, which they already doing for multiple platform and they have very nice pipeline and we like the idea how they are building the artifacts and all sort of the things because it will give us a bit edge because we don't need to build every artifact for ourselves. That is the main thing. And they have very nice dashboard and all sort of information. So we thought let's hook up with the KernelCI.org CI/CD pipeline and start posting the or integrate our lab. So that was the one. So we start working with the kernel org. I think in October 24 we started, and to that is the one. And other thing like doing so we opt like for LAVA framework to test to manage the test device and push the test results and all sort of information. So during that discussion with Kernel org, at that moment they was having only one model, that is master-based model, and they call it internally Kernel CI 1.0 model, where they are triggering the jobs to the labs. But for us, was not useful because we sit behind the firewalls. So that is the part now. And for us to open up is a big deal. Like we can't come out from the firewall. That was the key, and the discussion went for around a big time frame, like 1 or 2 months, and they have come up with some idea. They had that idea, but they never implemented that. They come something called Kernel CI labs. So you can have your own labs. You read that. So I go through the architecture, but so the new model is called KernelCI.org 2.0, which these guys will not trigger the jobs. It is a kernel CI lab responsibility to consume the artifact, test it, and push the results to their dashboard. So a brief introduction, maybe some you guys already have seen that. The kernel, this is architecture of kernel CI.org, how it works. So I will focus mostly here and our lab. So master some software which these guys call it, and they trigger the artifact based upon the how monitored kernel heads are moving, and they trigger an event which is in a JSON format. So our lab, which is Qualcomm lab, listen to these events, and we will react upon that. We test our devices and push these results back to Maestro, and later they will push it to KCIDB. Then you can see those results on their web dashboard. So that is the thing. Bit of more designing part. So the left side is the Qualcomm Kernel CI LAVA architecture. Right side is Kernel CI org CI/CD infra. So, bit of a so we try to leverage their code, which is called Kernel CI core, and the pipeline core deal with the, as name suggests, core will deal with the Maestro events, how to parse them, and all those sorts of things. And Kernel CI pipeline main kind of thing is like to consume and trigger a job to the Lava. We had our own Lava server connected to do Lava workers. So once we have the Maestro event trigger, which is a JSON format, we consume it in the Qualcomm Lava through the pipeline. We parse it, send to Lava server, to the worker, then the results will propagate back. And there is one microservice run there called Lava callback, which help us to pass the result in the way which Maestro API likes. So using this thing, we submit the node to Maestro APIs. Maestro API node then again like sync the data to core DB. They call it core KCI DB. Then you can see through the dashboard how it looks like. So this is what kernel lab architecture looks like. So so this is the very recent, not very old, I think 2-3 weeks back. We completed a pipeline, and now our few of the device are already showing in Kernel CI dashboard. You can see those, and we are already reporting the boot. Right now it is baseline boot only. We are reporting the status. Couple of bug we got in the some staging branches, but yeah, this is the thing. So these right now we support 3 targets as listed: RB3 Gen 2, QCS 8330 RIDE, and QCS 91 RIDE. Yeah, challenges. So as new thing starts, challenges was to understand the kernel CI workflow and how their CI/CD work. So that is the main challenge we faced, because this was entirely new for us, and even Lava is entirely new for us. How Lava works is that I started from zero, so that was the two thing. And the Jinja templating, that is also like we invested a lot of time there, how it works and how it renders a job. So that was the one. And Lava framework also like one of the good time to understand that, but it's a good tool. Nice to have that. And the designing of the kernel CI LAVA architecture, because we sits behind our firewalls, as I told, it took a lot of time to make things working with the kernel CI guy with the firewall. So that is the one of the good thing.
This is what you have not written down here. I am Qualcomm.
Hi, Tilak.
So one of the things which you have not written is dealing with big company IT organization, which is kind of a security enforced on us, and creating a DMZ zones, and then what data we upload, what data we download, is every byte is being scanned kind of stuff. So I think we spent good amount of time in setting up any of this infrastructure, I guess few to explain them that what Lava transfers or what test case we are downloading it actually. So the biggest time is that, okay, you can say, why Qualcomm is not doing this, right? That's one way of saying it. And but then CCI, because Qualcomm is an IT company, the CCI is so important for us. It's what we call company confidential information. So that took us, I think, a long time apart from these challenges. So I just want to mention that because it's not like we do not want to do this. We want to put maybe 100 SOCs here. That's not an issue. It's just that the data we send, it's everything is scanned. So yeah.
A bit of summary, whatever we gone through the initiative, we talk about the our initiative to support the community through the Qualcomm Lava Lab. That is one which is already like up and running for few platforms. And the main thing to achieve all this sort of, all these CI/CD pipeline is using only open source tools in the testing. That is the key part. So, and we are leveraging the Kernel CI 2.0 workflow. That means we are triggering the job on our platform by reacting on the APIs and publishing back the results. And the Kernel CI dashboard for various platforms, which we already had shown here, is already up. So going ahead, what is the plan for us? So we are planning to bring more and more our platform on board, which covers like mobile, auto, and all IoT platform as well. So that is our plan. And right now we are only testing the baseline boot. So slowly we are ramping up to like integrate more and more test cases apart from the baseline. And we will be closely working with the KernelCI.org to optimize. There are few like optimization in the workflow we have identified, plus the enhancing their test coverage and all sort of information. So that is what we are going to plan.
We'll be also submitting our test definitions to Lava. So I think we kind of came out with at least 10, 15. We came out with a very
Correct.
simple test which we are executing on our platform today. So which we initially did internally, but that's just the beginning. And then we have our own test cases which we are open sourcing it. So we'll be all going to Lava. So we don't want to fork this test definition project. Just to be clear, we do not want to fork anything. Okay. So we did it initially for our just making sure that this Kernel CI 2.0 was not an easy workflow. I think probably we are the first one. I don't know.
Yeah, we are the first one.
For Gustavo to do this, and because they were also figuring out a lot of Google Cloud issues and whatnot, right?
We gave a tough time to them to make the
Motivation to contribute to the Kernel CI 2.0, maybe I cannot say for sure, but you can remember as well, right? So, and then I think one of the things we do not, we would like to improve is the web dashboard, I guess.
Yeah.
It requires, I think it's not intuitive at all.
Correct.
So we want to bring our ideas and contribute to one code. So that's our, and then bring many more SOCs actually. And we right now have a lab in Hyderabad, Bangalore, one in Chennai in progress, and one in China in progress.
Yeah.
So almost every Qualcomm office probably we can have all these many boards.
Yes, yes.
San Diego, I mean, we want to just put it dry run here. And San Diego is very easy to do in a way. We already have a landing team lab, so we already have DMZ zone there. So that's not an issue. So,
how do you have these boards wired up?
I'm sorry?
How are these labs wired up? Like how are the boards connected to the, is it a TPU?
Yeah, so we have now, what do you call, keep forgetting the name. But yeah, so we have Foundry spokes as well right now in the Qualcomm. So we got all the inputs from there. So right now we have one worker, one device, and then, but we will go with that, what you said about TPUs and stuff. So scale it and maybe make it more stable platform as well. So yeah.
This is kind of,
be a Lava upgradable as well, so that we do not stay on the older version of Lava. So and I think we are talking to Mathia. Sorry, what is his name?
Malus.
Yeah. So
Yeah.
Well, we can converse with them, we can give you some guidance too.
yeah, sure.
Workers,
Yeah, definitely. So we have a lot of goal. I think Yogesh is 100% working on that, and more people will work. We that. So yeah, or not. And then we fix it. So yeah, yeah.
That would be really helpful because I had to break my head for, you know,
Getting the hardware.
why this is only breaking on 845, you know.
Yes, so and then getting a support, giving a support to you because I have a hardware team ready to fix and solder kind of anything. And I think having a Qualcomm extension like this lab, I think it will be huge value add. So yeah.
I will be having always a reference, you know. Is it
Correct.
breaking only on me or somebody
Yeah.
else also
Yeah.
has the same problem?
Sure. Yeah, and I can keep giving you units, you know, kind of. So that's very kind of time.
It doesn't scale. It doesn't scale.
Yeah, yeah. So absolutely. And the big inspiration for us is TI, Texas Instruments, Sunishant work. So that's how I kind of got inspired last year from his talk in Embedded Open Source Summit, and that's where around that time we started. So it's almost 1 year, and it's going well.
And big thanks to Gustavo for guiding us all the thing, and plus Tirlok keep pushing us that we can do it, because there's a time when you really feel it's not working, right?
Keep supporting that project. So absolutely.
Yeah, thanks Tirlok. Yeah, so that's it.